Hi, welcome to my presentation. Today we will be talking about the history of artificial intelligence. You may be surprised to learn that artificial intelligence got its start all the way back in the 1950s. In an attempt to answer the question, "Can machines think?" Alan Turing designed a practical experiment. He created a game with a computer, a human player, and a human interrogator. The interrogator asks questions and tries to identify who the human is. Turing said if the machine is able to successfully fool the interrogator as often as an actual person, it passes the test. Later in 1956, Dartmouth College hosted a summer research project on artificial intelligence. It was the first conference of its kind and was comprised of computer scientists, mathematicians, physicists, and others, notably John McCarthy and Marvin Minsky. It was at this conference that the name artificial intelligence was coined, and plans to roadmap AI research, algorithms, and programming languages were made. In 1958, Frank Rosenblatt, a psychology professor, was inspired by neural networks in the brain and created an algorithm that would come to be called the perceptron. It was an algorithm with only two possible inputs and was designed to make predictions. The predictions could be either of the two inputs, which could stand for anything, yes or no, or black or white. The perceptron would guess. If it got the answer wrong, it could adjust and get more accurate with the more information it was fed. AI continued to grow steadily into the 60s and 70s. In 1966, Joseph Weizenbaum created the world's first chatbot named Eliza. Eliza was designed to emulate a psychotherapist and talk to patients. The program recognized keywords and asked open-ended questions, allowing it to have lifelike conversations without fully understanding what was being said. Throughout the mid-60s and early 70s, the Stanford Research Institute created and worked with a robot called Shaky. Shaky had been outfitted with a variety of sensors to help perceive the world. Connected to a computer by radio, Shaky could be given a task and independently form strategies to achieve its goal. Stanford's work with Shaky laid the foundation for the self-driving and assisted vehicles that are available today. From the mid-70s to the 80s, technological limitations created substantial bottlenecks that slowed AI's progress. This led to negative evaluations and a significant drop in funding. This time is referred to as the first AI winter. AI industry slowly recovered into the 80s, where expert systems eventually took center stage. These systems relied on if-then logic rules to answer specific questions, and each rule had to be programmed by hand. Because of these limitations, expert systems often failed or ran into problems and could only handle very specific queries. In 1986, David Rumelhart, Geoffrey Hinton, and Ronald Williams successfully implemented backpropagation, opening up the door for data-driven learning and eventually our current era of deep learning. While extremely limited by the power of the technology of the time, it proved the potential for more complex systems was possible. Despite the breakthrough into backpropagation, artificial intelligence hit another plateau by the late 80s that continued into the 90s. This was due to an economic crash and the abandonment of AI expert systems. These systems relied on technology that was already becoming obsolete by the end of the 80s, and managing and writing the thousands of if-then rules made them just too expensive to justify. Recovering from the crash in the 80s, the AI industry spent some time rebranding. Powered by the next generation of computers, artificial intelligence began to shift away from rule-based logic systems in favor of mathematically driven data models. These machine learning algorithms were much more flexible than the expert systems of the 80s and were able to improve themselves. The more data they consumed, the better they became. Demonstrating the growth of AI, IBM built Deep Blue, a computer designed to play chess. Facing off against the reigning world chess champion, Garry Kasparov, Deep Blue used brute force computing to examine up to 200 million chess positions per second and used statistical analysis to make its plays. Later in 2007, ImageNet project was created. This visual database was hand annotated with over 14 million images and was used to train AI models in image recognition. It was a great success and showed the value and need for large data sets to further advance AI. Building on ImageNet's influence, AlexNet combined multi-layered neural networks, large data sets, and modern GPUs to lower error ratings by over 10%. This set the stage for the deep learning we use in AI today. The image on the right is an example of AI training in image recognition. In 2017, Google researchers revolutionized the AI industry with their Transformer, changing the architecture of neural networks and allowing for more efficient and accurate responses to prompts. Looking back at the last 6 years, AI has already come a long way. In 2020, Google DeepMind's AlphaFold was able to discover how to predict 3D structures of proteins. This revolutionary tool allows scientists to study and explore on a level they were never able to before, and is significantly useful in drug discovery and biology. In 2022, ChatGPT launched publicly. Now ChatGPT answers approximately 2.5 billion prompts every single day. 1 year later, Google began to roll out its integrated AI search feature. And in 2024, the European Union enacted the first formal set of regulations on AI. Some noteworthy restrictions are on social scoring systems, biometric categorization, emotional recognition at work and school, and predictive policing systems. So what's next for AI? What kind of future can we anticipate? In the future, we can expect to see large language models transform into more sufficient agents and assistants. AI will be able to handle more complex processes and multi-step tasks. Automation will likely become more and more common, with robotics playing larger roles in our day-to-day lives. Artificial intelligence will make it possible for us to maximize our impact and overcome obstacles previously thought impossible. Thank you for listening to my presentation on the history of artificial intelligence. I hope you learned something interesting. Here is my work cited, and this concludes my presentation.